Hello, welcome back to the Daily Spatial Dose. Today we'll show you how we can map Tim Hortons locations as points over a shapefile of Toronto's neighborhoods. Next, we need the data. We're going to use GitHub to assess our CSV file, which is quite convenient to do. So to do that, I've got my base URL that I'm going to use. I'm just going to copy paste it over here, and I have my shapefile parts that I've predetermined, and I'm just going to paste it over here. And let's go quickly through the code so that you can understand better what I'm doing here. So the base URL is basically the location of my GitHub, where under Daily Spatial Dose you have all the files we use. And the shapefile parts, a shapefile is divided into a series of parts: shape, SHX, which is the geometries, the database file, and a projection. And we have to create sort of a loop that allows us to load all of these parts to the system. So we are just declaring for part in shapefile parts, which would be basically the SHP, SHX, DBF, and PRJ. We are doing a request using URL lib, and that request takes the base URL, which is this one, and copy pastes the neighborhoods plus the part, which would be this. It iterates and downloads neighborhoods.shape, neighborhoods.shx, neighborhoods.dbf, and neighborhoods.prj. And when doing this, it allows us to download all of these 4 files that constitute a shapefile. So let's remove the comment here so we have that here inside, and that's basically where our first line of code starts. But as always, the first thing that we should actually do to make it efficient for us would be to add our libraries. So we're going to import a series of libraries here. Import GeoPandas as GPD, and then we are going to add the import matplotlib, and under matplotlib we're getting the pyplot as PLT, and import. But whenever you want to download something from the web or from a server, URL lib is going to be the way to do this. So we can now execute this command, and we have the libraries now with us. And let's just take this code and put it over here so it becomes a better flow. Okay, so we have the base URL, and actually going to make it different. So I'm just going to download the base URL. So I've got now the base URL in memory, and now I will add to this the shapefile requirements. So it ran without any issues, and now I've got the shapefiles with me. So within that URL, we still have our Tim Hortons locations. So I can actually say CSV URL, and we are going to call it base URL, which already has been defined, and plus Tim Hortons CSV. In doing so, we are doing exactly the same thing. We're adding sort of, and I'm just going to copy paste this. We would have, and I'm just going to put this here as a comment. We will basically add this like this. And with this set of instruction, I'm telling to get the base URL plus this file extension or this file name into my object. Okay, so I can load this, and I'm just commenting it here so you know exactly what you're getting when you do base URL plus Tim Hortons CSV. Once you've done that, we can actually start doing some reading of the file itself. So let's try to read the data file that we will have available, and we'll just use GPD. So GPD again is part of our GeoPandas. To that we will read the file, and we'll read the file, which is the CSV URL that we've previously defined over here, corresponding to this file. So now we have the object Tim Hortons DF, so Tim Hortons data file that we've created, and we will have now, we'll convert it into a geodata frame. For now, as you can see, it's simply CSV file. And actually, we can just read this quickly. So we use the head command, and here we can see how it's organized. We've got stores, ID, we've got street, city, province, latitude, and longitude. And to make it spatial, we require the usage of latitude and longitude to convert it. So let's create it into a geographic data file. To do that, we will use and create a new file called Tim Hortons GDF. And as Tim Hortons GDF, we'll use the GeoPandas library again and read, and we'll convert it into a geodata frame actually. So let's convert it using the file that we have. That would be the Tim Hortons DF that we've already defined. And now comes the interesting bit. So we define the geometry, and we want to create latitude, longitude into points. So we do GPD and we convert it to points, and we'll use points from X, Y coordinates, right? Because that's what we have as lat long. So we use X, Y coordinates, and now we define this as Tim Hortons DF because that's exactly where they're located. And within that location, we go long, and Tim Hortons again. That location, we have the file over here, long and lat, right? So we'll just call this up here as well. So just to check what we're doing, we are defining a geodata file, and we're calling the instruction geodata frame within the library of GPD that we've imported right in the beginning. And once we've imported that, we are using the Tim Hortons CSV file that we created, comma. Whenever we have a new set of instruction within a comment, we have to put a comma to separate. And then we are defining the geometry. That is important because otherwise we're not able to convert these into points. And we are using the library's function, which is points from an XY set of coordinates. Remember that the X and Y coordinates are lat and long. So we are calling Tim Hortons DF, which is our data set that we can visualize here. We use the head function to visualize, and we are using long and latitude to call out to these values. And now we can just run this, and it should have worked without any issues. And now that we have the points defined, we should define the projection that we're going to use. So let's go with Tim Hortons GDF. And to set a projection, we can use set CRS, and we define the projection at hand. So we use 4326 in place equal true. And that's the command that we use to define the projection. Oh, and of course, mind the spelling, in place. Okay, good. So now we've got the Tim Hortons in place here, created with a set of projection, and you will see this is now a properly created geodata file. The loading of the shape file that we have with the neighborhoods is comparatively easier. So we can just go neighborhoods, because we don't have to convert anything. Here we had to convert the latitude, longitude points, coordinates, to a point. Here we don't have to do any conversion whatsoever. So just going to create neighborhood GDF and importing a read file. A shape file is pretty easy now, so we can just go and import this here as neighborhood shape file. And now we have the neighborhood shape file as a GDF file as well. We are almost done. We've imported both our files. We have actually done more than that. We've converted the latitude longitudes into a point, and we've taken that information and we've projected it into 4326. So this allowed us to create sort of an initial view of the file itself. And I should know that 4326 is WGS84, and actually can put that here as well so that we don't have, let me just comment that here. So we're projecting into WGS. And for those that are not familiar with the WGS84 projection, it's the World Geodetic System 1984 projection, which is a global projection. So this will have some impact on not making the prettiest of maps, so we're not visualizing it as a Mercator projection at a local zone, which would be 17N. We can leave that to a later tutorial, how we can project and reproject so it becomes better in terms of doing more spatial analysis. But we are for now just interested in visualizing, and both our data sets can be visualized like that quite easily. So now that we've actually imported the points and defined the projection and imported easily our neighborhood shapefile, we can start drawing our map basically. And actually I'm going to comment this: drawing, creating the map. To do this, we're going to define AX equal to neighborhoods and the GDF that we've created, and we will just plot it. And by plotting it, we can choose the color that we want to use. I'm just going to take it for white, and we can define the edge color as, let's do that, the dark gray. Well, let's do it gray. We can also define a figure size. Actually, let's make it a bit like this so it becomes, I think, fig size. We are going to define this as 10, okay, which defines the parameter. Tim Hortons GDF that we've created, and we'll plot these as well. AX equal AX. So we'll do color, let's do that black. Marker size, so that's the size of the point for now. Finally, we can put a title to this. Let's put it Map of Tim Hortons in Toronto Neighborhoods. And then we can do plot the labels. So let's put the labels for longitude, and plot the Y label, latitude. And to make it all work, we just have to call the plot function and show. Alright, here you have it. You have now mapped the longitude and latitude of Toronto neighborhoods. Thanks very much for watching. Please don't forget to like, share, and subscribe. Thank you.